All right, chapter 5 is all about proofs, and I think that 5.1 is the hardest section just because you're kind of sort of like, what is it asking me to do? 5.1 is going to organize it into either reciprocal identities, which would be like sine, which would be like sine is the same thing as 1 over cosecant, okay? So a reciprocal identity, it could be a quotient identity, which would be like tangent is the same thing as sine over cosine. Okay? We'll get some Pythagorean identities in there. And then we may have some even odd identities in there. So, again, I think 5.1 is the hardest just because it tends to make you wonder what on God's green earth is going on. So here we go. We're just going to slap this thing in here. One of the ways, I printed this off so it's going to look different on your screen than it does on the paper. So like the one here applies to the one here. This is just multiple choice, and number 2 is multiple choice. One of the hardest things that will probably you'll struggle with is the fact that they're writing cosine x times cosecant x equals, and then what they're really doing is rewriting what's on the left onto the right. Okay, so you just need to determine what's different. So if I'm looking at cosine times cosecant, well, the cosine and the cosine are the same, which means somehow they flipped it. I'm trying to get it and maneuver it and manipulate it into being a cotangent. So again, it threw me when I first started working with this software. They're not leaving the left side alone. They're rewriting the left side on the right side. So don't think that they all of a sudden said cotangent is cosine. Wait, what? I don't know what's going on. Just turn around and look at the fact that cosine repeats here and here, which means they've done something to cosecant. Well, what do I know cosecant is? Well, really, I only know one thing that cosecant is, and that's going to be a 1 over a sine. And how did I come to that conclusion? I know that cosecant is the exact same thing as 1 over sine because it is a reciprocal identity. Okay? So I'm not seeing that down here. Well, it's not even odd. Well, what did I do? I rewrote it in terms of sines and cosines. So you're just going to kind of have to sort of fight your way through it and decide what their reasoning is. They're trying to give you a path to go on. Okay, but the path may not be very obvious. So anyway, why can I now rewrite this thing as cosine times 1 over sine? Why is that magically cotangent? Because cosine over sine is cotangent, and that's by a quotient identity. So if we have, well, look, there it is. So I've got a quotient identity there. So what you're doing is use that little packet that I gave you at the beginning of when we started chapter 4, and it's like 4 pages long, but I stapled it, and it has all the trig identities on it. What you want to focus on in section 5.1 is, again, the quotient identities. Maybe you rewrite in terms of sines and cosines, flip it for reciprocal, anything like that. Okay, so basics, but it's just kind of weird to walk yourself through it. So this one says I want to go from cosine times tangent times cosecant, and I want to magically end up with a 1. And so I've got to figure out which method they used. And again, I'm not going to do every single problem in this thing because there's like 20 of them. So I'm just going to start talking you through. And if you get stuck on a particular one, you can email me and ask. But what do you notice is first? Cosine is first. So cosine, 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 cosine. Well, that's fine. All right, so tangent. Tangent is second. Tangent, 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 tangent. Well, what I have here is in their second iteration of this problem, I've got cosines the same the whole way down. So what they've done is they've changed tangent. So what is valid? So tangent is the same thing as sine over cosine. He's okay. Tangent is not the same thing as cosine over sine. So I'm going to knock off that one. So this is out of the running already. Okay? Well, tangent is the same thing as sine over cosine, so he's good. Tangent is not the same as cosine over sine, so he's out of the running. So now I've narrowed it down to 2 options. Cosine, cosine, cosine is first. Tangent is the same thing as sine over cosine, sine over cosine. So now I just got to fight with cosecant. Cosecant is going to be the reciprocal of sine. So which one says that this is the same thing as 1 over sine? Well, that's 1 over cosine, so it's not him, which means it must be C, because that's your 1 over 1 over sine. So what happens is those reduce, these reduce, and you're left with 1. Okay? So another one, what can we do? We can say, I don't know. Which of the following 4 statements establishes the identity? So everything works. I've got sine squared minus cosine. That's the same all the way down. So I've got to magically, they just said equals 1. What the heck? All right, so I got to figure out what they did. So what I want to find out is work this way and see what's valid. So I've got a sine squared minus. So here's a sine squared minus. This one just says magically 1. Well, that's stupid, so he's gone. Okay. This is sine squared minus. This is sine squared minus. So now I got to figure out among these 3 choices, obviously they changed cosine squared. So what's the valid answer? So my valid answer is going to be using Pythagorean identity. I know that cosine squared is the same thing as 1 minus sine squared. So there's my 1 minus sine squared. So these 2 just got knocked out. So that's going to be that one right there. Well, now if you distribute this negative, I'll end up with sine squared minus 1 plus sine squared. Well, a sine squared and another sine squared is 2 sine squareds. So it must be A. So again, you're just going to sort of have to kind of fight your way through this and figure out what's going on. And honestly, that's the learning of it. I know that's not what you want to hear, but that's the learning of it. So I have cosine minus, and I got to do something with secant. I don't even know what to do. So I'm trying to get this into a multiplication problem. So I'm betting if I get a common denominator, I'll be able to make it work. So if I have cosine minus secant, well, they have got a cosine minus, well, I really only know one thing to do with secant. And that's going to be to rewrite it as a 1 over cosine. Okay? So now I've got cosine minus 1 over cosine. Why am I allowed to do that? Because look at step 1. It is either a reciprocal identity or I rewrote it in terms of sines and cosines. So, oh look, it's reciprocal. Okay? So now what do? And now it's just kind of sort of, well, heck, I don't know. What did I do? So what you have is cosine theta minus 1 over cosine theta. Okay, these little drop downs will give you a hint. So, well, there's not a common factor. I'm not going to do that. How about combine using a common denominator? So my common denominator would be cosine, which means I need to multiply this side by cosine on top and bottom. Okay, so that is a very, very valid option. And now you can kind of sort of see I've got a cosine squared minus 1. And that could very easily be changed into sine squared because of a Pythagorean identity. So what I have right now is cosine theta minus 1 over cosine theta being a least common denominator. Well, now I can use a Pythagorean identity to rewrite this thing. The problem is that the Pythagorean identity says 1 minus cosine squared, which means you're going to have to multiply or divide out a negative. Okay, so I have a negative cosine squared theta plus 1. Okay, and so now it's a 1 minus cosine squared, and that's still over cosine. And so now that turns into a sine squared that's negative over cosine. Okay, so all I did was apply Pythagorean identity. So at this point, what you have is a negative sine theta times sine theta over cosine theta. So what is your final answer? This just reduces down. You've got your negative, you got your sine, and that turns into tangent based on what? How do I rewrite this as tangent? That's going to be because of a quotient identity, because this is division. Okay? So there's a few more in here, and I know that probably does not make you happy at all, but literally you're just going to have to kind of sort of fight your way through it. And I think 5.1 is the hardest. I'm trying to see if there's anything random. So this one, it's feeding it to you. So the tangent stayed the same, the secant stayed the same. You got to change cotangent. So what are you going to change cotangent into? Well, I know that cotangent is the same thing as cosine over sine, and that's by a quotient identity. Okay? So you just got to sort of fight it out in there. This one, I don't even know. I would just try things. Try distributing. That'll be a sine squared plus. And then cotangent is the same thing as cosine squared over sine squared, so your cosine squareds will reduce. And then, I don't know, you're probably very, very frustrated. I don't know, it's a whole lot easier in person because you can ask me questions. So that literally is what you're going to be doing throughout this thing. When you get to ones like this, which I already know what you're going to do, you're just going to hit A, check, B, check, C, check. But if you're trying to get through it and actually understand, work it from both directions. Okay, so how can I rewrite cosine plus secant? How did I get that from out of here? And I don't know if this is the right answer or not. I do know that I've got a cosine plus a secant. That would reduce. So do you see how that doesn't match? So that's not the right answer. I do know that I have this. So that would reduce, and that gives me the right answer. Okay. This one, nothing reduces because the sign in the middle is not the same. So work at it from both directions when it gives you these multiple choice ones. And then, like I said, you're just going to have to sort of fight it through. But email me if you've got questions. So I think there's, how many's on there? I just showed you all the answers. There's 16 on there. So, but literally, just fight it through, and what I'm going to do is I'm going to tell you what you're working with on each section, and just give you a couple of examples to get you through. But that is 5.1, and I'm sorry that's kind of crappy. But please email me if you have questions.